this module, we are discussing about the structure of an atom. As you all know, the existence of atom has been proposed since the time of early Indian and Greek philosophers. The word atom has been derived from a Greek word atomio, meaning non-divisible. The first definite theory about the structure of matter was put forward by John Dalton, and his theory was called Dalton's atomic theory. According to Dalton's atomic theory, matter consists of smallest indivisible particles called atoms. Further studies reveal that atom consists of still smaller fundamental particles such as electron, proton and neutron. Now let's discuss the discovery of electron. Electrical nature of matter has been known from ancient times. Faraday's law of electrolysis suggested the relationship between electricity and matter for the first time. He proposed the name electron for these discrete units of electricity. The electron was discovered by J.J. Thomson at the end of 19th century during the studies of the passage of electricity through gases at extremely low pressures. These experiments were known as discharge tube experiments. Under ordinary conditions, gases are poor conductors of electricity. However, when a high voltage is applied to them at very low pressures, the gases become conductors and electricity begins to flow in the form of rays. These rays are called cathode rays. Cathode rays start from cathode and move towards anode. Cathode rays travel in straight line in the absence of electric or magnetic field. These rays are not visible, but the behavior can be observed with the help of fluorescent or phosphorescent materials. Rays possess heating effect. These rays affect photographic plate. Charge of electron is determined by Millikan's oil drop experiment. An electron can be defined as a subatomic particle which carries 1 unit negative charge and has a mass equal to 1 by 1837 of that of hydrogen atom. The discovery of proton was by E. Goldstein, when he found a new kind of ray in addition to cathode rays which is streaming behind the cathode ray tube. They travel in opposite direction. They were called anode rays, positive rays or canal rays as they consist of positively charged particles. A proton can be defined as a subatomic particle which carries 1 unit positive charge and has a mass equal to that of an atom of hydrogen. Neutrons were discovered by James Chadwick. A neutron is a subatomic particle with mass equal to that of hydrogen atom and carrying no electric charge. Now let's try to understand the terms atomic number and mass number. The number of unit positive charges carried in the nucleus of an atom is called atomic number, denoted by the letter Z. Atomic number is equal to number of protons in the nucleus, which is also equal to the number of electrons. The sum of neutrons and protons in the nucleus is known as the mass number, denoted by the letter A. Mass number is equal to number of protons plus number of neutrons. Isotopes, isobars and isotons. The atoms of same element which has same atomic number but different mass number is called isotopes. The atoms of different elements having same mass number but different atomic number are called isobars. The atoms having same number of neutrons but different mass number are called isotons. J.J. Thomson's model of atom. The first symbol model was proposed by J.J. Thomson, known as Thomson's atomic model. He proposed that an atom consists of uniform sphere in which positive charge is uniquely distributed. The electrons are embedded into it to give the most stable electronic arrangement. This model was like pudding with raisin embedded on it. Therefore, this model is also known as plum pudding or raisin pudding model. An important feature of this model is that mass of the atom is evenly spread on the atom. This model explains some of the non-properties and electrical neutrality of atom. However, it was discarded when Rutherford and his co-workers observed unusual scattering of alpha particles by the metal foils. Since the model could not explain experimental results, it was therefore discarded. Rutherford scattering experiment. Hans Geiger and Ernest Marsden performed a series of experiments called Rutherford scattering experiments. In the experiment, they bombarded a target of atoms by subatomic projectiles. These projectiles, called alpha particles, were obtained from radioactive substance. Alpha particles are high energy positively charged helium ions having +2 charge. These alpha particles were bombarded on a thin foil of gold. In the experiment, the radioactive substance is placed in a lead block through which it falls on the gold foil through the narrow slits. In order to detect the alpha particles after scattering, a movable circular screen coated with zinc sulfide is placed around the gold foil. When alpha particles strikes the zinc sulfide screen, these produces flashes of light or scintillations. He observed from the experiment that most of the alpha particles pass through the gold foil undeflected. A small fraction of alpha particles deflect at small angles. Very few of the alpha particles appear to rebound back. Rutherford concluded that as most of the particles pass through the foil without deflection means there is large empty space inside the atom. Since some of the alpha particles are deflected at certain angles means there is heavy positively charged mass present in the atom. The mass must be occupying a very small space within the atom because only a few alpha particles suffered large deflections. The positively charged heavy mass which occupies a small volume in an atom is called nucleus. It is present at the center of the atom. Electrons are revolving around it in circular path called orbits. Drawbacks of Rutherford's model. According to Maxwell, accelerated charged particles emit electromagnetic radiations. Electron is a charged body and hence emits radiations. Ultimately, the electron would collapse into the nucleus. So, Rutherford's model was not in accordance with Maxwell's theory and could not explain the stability of an atom. Rutherford could not say anything about the arrangement of electron in an atom. Rutherford's model also failed to explain the existence of different spectral lines in hydrogen atom. Bohr model of atom. To overcome the drawbacks of Rutherford's model of atom and to explain line spectrum of hydrogen, Niels Bohr, a Danish physicist, proposed a model of atom which is based on Planck's quantum theory of radiation. Basic postulates of Bohr's model of atom are: an atom consists of a small heavy nucleus and electrons are revolving around it in certain circular paths called orbits. Orbits are associated with definite energies and are called energy shells or energy levels. The energy of the electron in the orbit does not change with time. This means that the energy of electron in a particular energy shell remains constant. Therefore, these orbits are also called stationary states or allowed energy states. Only those orbits are permitted in which the angular momentum of the electron is a whole number multiple of h by 2 pi. Hence, this postulate introduces the concept of quantization of angular momentum. Energy is emitted or absorbed when electron jumps from one energy level to another. The higher energy state is called excited state. The amount of energy emitted or absorbed is given by the difference in energies of two levels. Delta E is equal to E2 minus E1. Explanation of line spectrum of hydrogen. Line spectrum observed in case of hydrogen can be explained using Bohr's model. When electron jumps from lower orbit to higher orbit, it absorbs energy. The amount of energy absorbed or emitted may be given as delta E is equal to EF minus EI. Now, EF is equal to minus RH by NF square and EI is equal to minus RH by NI square. Hence, delta E is equal to minus of RH by NF square minus of RH by NI square, which is equal to RH into 1 by NI square minus 1 by NF square, which is also equal to 2.18 into 10 raised to minus 18 joule into 1 by Ni square minus 1 by Nf square, where we know that delta E is equal to h nu. Nu is equal to delta E by h. Hence, nu is equal to delta E by h is equal to RH by h into 1 by Ni square minus 1 by Nf square, which is also equal to 3.29 into 10 raised to 15 into 1 by Ni square minus 1 by Nf square hertz. In terms of wave number, nu bar is equal to RH by Hc into 1 by Ni square minus 1 by Nf square, which is equal to 1.09677 into 10 raised to 7 into 1 by Ni square minus 1 by Nf square, where RH is the Rydberg constant whose value is 1.09677 into 10 raised to 7. When the electron jumps from all energy level greater than n equal to 1, the lines observed fall in the ultraviolet region. These lines are called Lyman series. The lines obtained when the electron jumps to second level from higher levels fall in the visible region. These are called Balmer series. Transitions from higher energy levels to n equal to 3 produce Paton series which lie in the infrared region. Transition from higher energy level to n equal to 4 produce Brackett series, and from higher energy level to n equal to 5 produce Pfund series, and these series lies in infrared region. I hope you all get a fundamental idea about the structure of atom. Thank you.